All right, hello everyone. How are you all doing? It's great to be among people, definitely. Thanks for Blueprint team for organizing this and having me over. Yeah, and so on. Okay. Anyway, today we'll be talking about speed in your CI setup. Have a think for yourself. What was the worst story that you've had in your CI/CD kind of career or setups, basically? What was the hardest to debug, the most agonizing thing to kind of you had to deal with? Because yeah, I'm sure everyone who's kind of worked in the industry for at least a couple of years has some kind of frustration stories with CIs anyway. Anyway, my story went like this. I woke up one morning, and obviously the first thing I do is check Twitter. Second thing I do is check my email, and you know what's waiting for me at the top? It's an email from my CI provider telling me that the build has failed. Build I kicked off before I left work last night. Okay, it happens. That's fine. We've all seen that. We've all been there. Open up the laptop, have some breakfast, make some coffee, punch in some changes, kick off another build, and off to work we go. This story is about 6-7 years old. I was working on a mobile team, so for a retailer, and basically we were doing everything as right as you could. So we were following solid principles. We were adhering to, like, the app was designed according to clean architecture, so really well designed. We were doing everything test first. So, and that only included unit tests, but also functional tests. So the whole thing was and agreed upon those functional tests with the product manager, with the development team, with the QA engineer on what the features were supposed to do, which was it was really staggering for when we were doing this. And anyway, we were doing everything right. We couldn't go wrong, right? Oh well. Anyway, I was just about to finish my day, close off for the day, and when I get a new email, and yes, it's our friend the CI again. It says build has failed again. I mean, 2 in a row sucks, but we've been there, so okay. Open up the laptop again. Some changes. Maybe I missed something stupid, so I probably missed something stupid. And do this again. Kick off the build, go home, and next morning, surely it's gonna be all good, right? Well, no. And the next day, the story repeats. The day after, the story repeats again. And I think it went for a week or so. It was pretty staggering because we couldn't do anything, and we were looking at a backlog of features and bug fixes and everything that started to look like this. This is that airfield where they had lorries parked at Christmas. So this is not a good place to be in if you're kind of trying to deliver things on time and deliver things at all, because you can't really ship anything. And the team was basically just stuck looking at this red light saying, build has failed, you can't ship anything, there is nothing we can do. And that's where we really started thinking, hey, should we just kind of disable this whole thing? Disable all automation, build our things manually, test our things manually, go back to how things used to be in the good old days? I mean, yeah, we could do that, but that would be the equivalent of ships turning around and going around Africa because that thing was stuck there. It's not safe. It's definitely not optimal. It's always better to just fix the problem that you have. That's why we're considering red builds or failing builds as a signal and not something that's really kind of negatively impacting our whole teams. And hopefully, with this talk, you will have some idea of how to kind of really get from this agonizing CI story into something more pleasant and useful that gives you an actual signal of your app's quality. Anyway, my name is Dan Marken. I've broken many apps, I've broken many builds, and yeah, I'm a developer advocate at Circle CI, and it's really great to be here again. Yeah, so this talk is titled "The Need for Speed." No relations whatsoever to the TV franchise or movie franchise. And yeah, we'll be covering some practical tips and tricks for optimizing your CI/CD builds. I work for Circle CI. We are the leading CI/CD platform in the world. We're helping teams all over the place build things better and ship faster and more efficiently. And yeah, we really operate at a staggering scale and cover any type of technology you can imagine, any programming language, stuff gets built on our platform. Well, this talk is not specifically about Circle CI. I am going to include some examples showing Circle CI configuration. And yes, like everything I cover here is technology agnostic, platform agnostic, vendor agnostic. But yeah, I'll be showing some YAML files that come from Circle CI. Anyway, the way this thing works, you configure CI/CD pipeline in this config file, config.yaml, which is part of your repository. This means that it's tied to the same Git commit that everything else is tied to, the whole code base, which is awesome because if this Git commit changes, and it's not going to change, the build, anything in the build can actually change. If only with a new commit you actually kind of change as well. In there, we are configuring our CI/CD pipeline. And this pipeline contains a set of workflows, jobs, and commands. Jobs are this atomic unit of configuration, which is an isolated in a specific environment. For example, a Docker image, Docker container based on a particular image that we specify with a set of steps. These steps can be command line instructions. They can be built-in steps like checkout, which gets the code at this repository, or kind of more advanced, complex commands that we define elsewhere. Workflows are where we essentially kind of orchestrate those jobs, and workflows get kind of executed when we are kicking off a build with a Git commit. So yeah, this thing then kind of runs all our tests, runs all our build, does anything you really want to do. Anyway, and yeah, we specify execution environment as well. Docker images, virtual machines, whatnot. Anyway, you have a bit of an idea of what's what now, so let's continue. So, do we know that we have a problem with our slow builds? Obviously, when your team wants to disable CI is the last time you really want to have, it's like the last possible moment you really need to acknowledge that you have a problem. There's earlier signs that you can detect. One is just kind of looking at how your build times are slowly growing. But that's not going to happen quickly because you're not adding 10 million lines of code with a single commit, hopefully. You're kind of, as you add new features, as you add new tests, your build times should slowly grow, which is not a really good indicator of today things were good, tomorrow things were bad. Then the other one is if your builds are sticking in the kind of broken state or failed state for a longer time. That's a good example as well, but how do you really keep track of that? Like if you don't have good dashboards for that, you're not really going to be able to kind of keep track of that. My favorite one is just ask your team. You're probably doing retros, you're probably doing team meetings, trying to kind of figure out better ways of working that works for everyone. and people are going to complain. They are going to complain about your CI setup, and yes, if one person complains once, sure, it's one signal. But if this is a recurring topic in 2, 3, 4 retros, consecutive retros, then yes, you do have a problem. So we've acknowledged our problem. Let's learn and understand how to actually measure this and what to measure. Obviously, the first one is measuring how long things take. For that, it's pretty easy. Did it finish? You can do that with any tool. You can just write a bash script to do it, which should be very useful. You can do it for you can do it for an individual test job, test suite, whatnot. It's very easy to get those measurements. But you can do much more. You can use much more advanced tools, because if you're using a modern CI provider, you will have kind of better analytics. You should have better analytics at your disposal. For example, which parts of your tests are more often failing, which parts of your which test suites are more likely to fail, everything. What's the percentage of time something is failing compared to everything else? So with Circle CI, we have this insights thing, which kind of shows you, yeah, basically that, like how long things have run on average, what's the 95th percentile of how things have been going, and so on. You can drill into tests. But yeah, like different providers might have different dashboards, different tools for that, but find which one you have and use that, really kind of understand what you can get out of it. It's usually out of the box. Anyway, now we know where our problem lies. We hopefully know which kind of parts of our test suites or test suites entirely are kind of running slower, or is it our build running slower? What's going on? Let's see how we can actually optimize our builds. I'm going to be covering a few practical areas to optimize. One is increasing the horsepower that you're throwing at this thing, because if you think about how CI builds execute, they execute on either, in Docker containers, which are based on some hardware, or virtual machines, again, based off some hardware. So really think of what hardware are you actually allocating to it. Sometimes you'll learn that you can run your local build on a laptop, a recent MacBook Pro or something like that, with 16 gigs of RAM in 2 minutes, whereas on CI it takes 10 minutes. And then you realize your CI has 1 gig of RAM allocated to it, and like 1 for vCPU or something like that. So yeah, think what is the good kind of ratio of kind of horsepower to, like performance to price for you, and what kind of time benefits you might see. It's very easy to toggle. Obviously, if you're running your own CI server, if you add more RAM, you probably need to order some from Amazon and then install it. But if you're using like a cloud-based provider, it's just like a one line of code to kind of specify resource classes. So yeah, if you go from medium to large to X large, see what happens. Like, do a few runs, and maybe it's gonna go fast. There's some diminishing returns here, and there's not, like, sometimes you'll seeing that benefit anymore, in which case it's a kind of smaller machine, because better tricks up our sleeve. Yeah, so we're running everything on the machines that make sense for our builds and tests. Next thing is to think how we can do things in parallel. By these I mean actually running things in parallel streams, as opposed to running everything sequentially. There is a lot of benefits in doing things asynchronously. For one, we can kick off many builds and tests and verifications, for example, security scans, static code analysis, unit tests, functional tests, integration tests at the same time. And you want the results of all of them, but you don't want to kind of run one after the other. The other one, which is probably even better, and in our case, that was probably the most beneficial feature that we didn't have at that time, was to split tests within a test suite. So we had a lot of functional tests, as you might imagine, and it's possible to actually split those within a single test suite across different parallel jobs, which is really, really freaking amazing. If you consider that you can have tests that run for, I don't know, 2 hours, 4 hours, 6 or 8 hours, hopefully not, across, 6, 10 jobs, which will run about that time. My favorite trick here is splitting time. With Circle CI, you basically just kind of tell it where the tests are, and it'll kind of figure out based on previous test runs which combination of tests works for like approximately same kind of chunks, same length-wise running chunks of work, if that makes sense. Essentially, you go split it into 6, 10-minute-ish jobs. That's a big, big, big improvement. There is other techniques. You can do it manually using some kind of environment variables that you inject into into your test jobs to kind of identify, I want to run this test suite, or do it by file, by class, and so on. So yeah, we're running in parallel. We're running things on the best machines that we want. What's next? What else can we do? We can, of course, utilize caching as well. Caching is nothing but deduplicating work. And split it into two categories. One is, and then what you actually built. What you need are your dependencies. So if you ever run npm install on a React application, you'll know what I mean. These things take a long time. There's also git cache, so git history can be cached, so hopefully that comes built into your CI provider. But yeah, dependencies are common culprit for kind of long-running builds, just because you've got something that loads for 30 seconds or 1 minute or however long that is each time, even though nothing has actually changed. For that, we utilize cache and make sure that you reuse that cache if the underlying dependency definition file hasn't changed, which is really, really cool. Other type of caching that's not really caching, but if you're doing things in a Docker environment, you can actually just specify the right Docker image as opposed to installing everything in a pre-built or on a base kind of Docker image. So if you've got any specific test tools, environment, things that you need to set up, like build an image and reuse that image. It's easy, and it can save you a lot of time because you're just taking that Docker startup hit instead. And then what you build is especially useful if your build times are actually slow, or if you have a really big kind of monolithic application that you're kind of building, and for that you might want to do something like intermediary caches for build steps. If you've used Gradle, for example, they do a lot of kind of intermediary steps for things like Android compilation especially. So you can easily save all those caches and have some time benefit quite easily. The other one is build artifact. So you're building an app for a series of tests. Build it once, store it, and then pass it on to subsequent jobs to run functional tests, to run some other type of analysis on it. And the other one is Docker layer caching. So if you're building Docker images, if that's the kind of output of your CI build, you can essentially cache those Docker layers and then just kind of reuse everything apart from whatever has changed. So thinking about Dockerfile, you got run, you got copy, you got move, you got imports. You can cache everything apart up to the point where it's actually changing anything. So that's like a really cool thing you can also do. So now we kind of exhausted all the kind of really hacky or like feature-wise tricks. Now we really have to think about how else can we optimize things, and that's by going a little bit smaller. In our case, as you might imagine, we were way too many functional tests. If every feature in your application is functionally tested for every possible path that we can imagine, you'll end up with a lot of tests that aren't really providing you any like really big value. So for that, you really have to think what are the critical paths and kind of cut some scope of those tests. Maybe have them as like a smoke test or something like that. But yeah, really think what needs to be functionally tested, what doesn't. Or run a subset of a build based on what you're actually doing. So if you're working on a feature branch, pushing a commit, you don't want the whole test suite. Maybe you want a subset. Maybe you just want to run the unit test or something like that. But on main branch or when pushing a release tag, maybe we want to run the whole thing. Yeah, so really think about that. You can also rely on nightlies for that. So do a nightly test of everything. That was kind of what I was doing in the beginning. So, but obviously it's not always the same. And obviously it's not a DevOps talk if we're not talking about teams, because teams are awesome and your humans are your best resource. And actually, sorry, this is the right slide to be still on. You don't want to have a single person know everything about your CI/CD setup, because if something breaks, that person then has to kind of focus all of their time on blocking everyone else. So really kind of get everyone up to speed to at least some level of how everything's set up, how everything's configured, so that they know like what they're looking for if they're trying to suggest any improvements, so they're not just kind of going to you in retros and complaining, saying, yes, CI sucks, CI doesn't work, it's slow, let's shut it down. You don't want that. You really want to get the whole team up to speed as much as possible. And yes, reduces the bus factor or increases the bus factor, which is always good. And yes, what's the right build time for your team? I don't know. You should know that. Because every team, every application, every software project is different. Every organization is different. So really think about whether you want your builds to happen in 5 minutes, or you can do 30 minutes, or you can do 2 hours, in which cases. But what you can do is check out our State of Software Delivery report, which is basically a collection of data points we collect on our platform and then release this. Actually, the new one is coming out in a few months. So this one was released 2019, so it's quite old. But yeah, no, November 2020, sorry. New one is actually coming soon. But yeah, you've got some comparisons around what people are actually looking for, what throughputs, in which industries and platforms and so on. Anyway, last point, CI/CD, although we all want to make it as fast as possible, is not a race, especially a race, because instead of looking at it as like a race car, which just needs to go from A to B as fast as possible, you're also trying to get some signal across, and that's the signal that tells you whether your app is any good or not, whether your app works or doesn't work. So yeah, should go fast, but also make sure that you're going reliably. That's why I'm saying, I can't really tell you how long your build should take, what's good and what's bad in your case, because you know your team, you know your product, and I don't. So yeah, think about it, doing it reliably, find a balance, and yeah, if you see red lights flashing, you should go and fix it, because that's how you ship things. Anyway, my name is Zan Marken. This was The Need for Speed. I hope you have enjoyed it. I've got a link in here, circleci.com/Zan, if you want to get a t-shirt, you want to get the slides, leave some feedback for me. Yeah, that was it. Thank you so much for